So yesterday, that is in last lecture, so we have first derived one reduction formula, that is reduction formula for integration of x raised to n e raised to x dx, and we use this reduction formula to evaluate some integrations. So what was the reduction formula one? So we call it as reduction formula one, that is integration of x raised to n e raised to x dx equal to x raised to n into e raised to x divided by a minus n upon a integration of x raised to n minus 1 e raised to x dx. So we use this reduction formula. Actually, we reduce this reduction formula using integration by part. So already we have seen it yesterday. Very simple. So just simply using integration by part, you can obtain it. So using this reduction formula, first we find integration of x cube e raised to x dx. So how we find this integration? Let us see. So actually we have reduction formula for x raised to n e raised to x dx. So integration of x raised to n e raised to x dx. So if we put n equal to 3 here, so then we can apply this reduction formula for x cube e raised to x dx, and using that reduction formula we obtain this equal to x cube e raised to x upon a minus 3 upon a integration of x square e raised to x dx. But to find this integration, so value of this integration we don't know. So again, so we should find value of this integration. See, so see what is value of this integration. So to find value of this integration, again we have to use same reduction formula, but it is for n equal to 2. So if you put n equal to 2 in reduction formula 1, so directly it will give us integration of x square e raised to x dx, and that is equal to this. Again, so value of this integration contains another integration, that is integration of x e raised to x dx. So we are not using here integration by part, we are using reduction formula to find reduction formula again and again to find so required integration. So what is integration of x raised to x dx? Again we will use reduction formula 1 to find this integration, and for that we have to put n equal to 1 in reduction formula 1. So using it, so what we did, so here see, so if we put n equal to 1 in reduction formula 1, actually, so this is reduction formula which already we have written above. So it gives us integration x raised to x dx, and that is equal to x raised to x divided by a minus 1 upon a. And here, so x raised to n minus 1, actually power of x is 1 here, so 1 minus 1, that is 0. So 1 means it will be 0, x raised to 0 into e raised to x dx. See, but what is integration? Here, simply you can find integration of e raised to x without using integration by parts. So the value of this integration is there, and which is e raised to x upon a. So putting this value, you find value of this integration. See, so value of this integration equal to this. So what we did next, we put this value here. That is in back substitution, you put this value here. So we obtain integration of x square e raised to x. So that will give us this integration. So if we put value of this integration here, so simply it gives us, see, value of this integration. So same we did yesterday. So here substituting equation 4 in 3, what we get? So it gives us value of integration x square e raised to x dx, and which is nothing but equation number 5. So again we put equation 5 in equation 2, and that directly gives us required value of integration, and it is nothing but e raised to x upon a after some simplification. In the bracket x cube minus 3x square upon a plus 6x upon a square minus 6 upon a cube, and that was the required answer. Same example, same type of example, that is example 2, we solved yesterday, that is integration of x raised to 5 e raised to 2x dx. So here, so we, in first example, we take particular value of n only. So a was general, so here we are taking both n and a. Yeah, so we are varying values of n and a both in example 2. So we have reduction formula. Actually, you can write it as a reduction formula 1. See, what is that? Same integration of x raised to n e raised to x dx, and that is equal to this integration. See, to evaluate this integration, we have to use this reduction formula. If you solve this problem that simply using integration by part, then this is not proper way. This is not method of integration which we are using here. See, so we are using here reduction formula to evaluate certain integrations. So this is method of integration. So this part we are seeing in this chapter. So see, so first we put n equal to 5 and a equal to 2 in reduction formula 1. So we get integration of x raised to 5 in terms of integration of x raised to 4. Again, we put n equal to 4. So it gives integration of x raised to 4 in terms of x cube. Then we put n equal to 3. Then we get integration of x cube in terms of x square. Then we put n equal to 2. Then we get integration of x square into e raised to 2x in terms of x. And lastly, we put n equal to 1 and a equal to 2 in reduction formula 1. So we obtain integration of x e raised to 2x dx, and we find value of this integration, and it is nothing but c. So this value of this integration. So what we did next, we put this value in integration of x square, means here c, and it gives us value of this integration x square. So that is value of integration x square into e raised to 2x dx we obtain. Again, we put this value in x cube, means here, and that gives us value of integration x cube. We put this value in integration of x raised to 4 here, and that gives us integration of x raised to 4 e raised to 2x, and we put this value here, and that gives us integration of x raised to 5 into e raised to 2x, and that was our required integration. So same thing we have did here. So we substitute equation number 6 in equation number 5. So from that we get value of integration x square e raised to 2x dx, and we call it as equation number 7. After substituting equation number 7 in equation number 4, so we get integration of x cube e raised to 2x dx. We call this equation as equation number 8, and after substituting equation 8 in equation 3, so we get value of integration x raised to 4 e raised to 2x dx, and we call this integration value of this integration as equation number 9. And finally, value of integration x raised to 4 e raised to 2x dx, that is equation number 9 in equation number 2, and we get required integration, that is integration of x raised to 5 e raised to 2x dx, and that will be our final answer. So that was the second problem which we have seen in last lecture. And after lastly, sorry, so I ask you to solve some problems at home. So hope all you will, yeah, already these are simple problems. Same problems already we have solved. So hope you all solve these problems. So we'll continue. So next reduction formula, that is reduction formula number 2. So just I will check. Only 3 students are there. Very poor performance. Yeah, it's okay. So next, that is reduction formula 2. Next reduction formula. Yeah. So second reduction formula is that is integration of, see, so second reduction formula, integration of x raised to m sine nx dx. What is value of this integration? And value of this integration is equal to, so simply I will write this value. So this equal to minus x raised to m c. So value of this integration is minus x raised to m cos nx divided by n plus m into x raised to m minus 1 sin nx divided by n square minus m into m minus 1 divided by n square, and it is integration of x raised to m minus 2 into sin nx dx. So this is the second reduction formula. See, yeah, second reduction formula, that is integration of x raised to m sin nx dx equal to minus x raised to m cos nx upon n plus m into x raised to m minus 1 into sin nx divided by n square minus m into m minus 1 divided by n square integration of x raised to m minus 2 into sin nx dx. To find integration of x raised to m into sin nx, so we'll use this reduction formula. And to find this integration, you should find integration of x raised to m minus 2 into sin nx dx. So the same process which we have seen in previous reduction formula, so we'll see here. So first we'll see how this reduction formula is obtained. See, so for that, just a minute. So what is derivation of this reduction formula? You can call it as proof. See, so using integration by parts, so we have, or we can write integration of x raised to m sin nx dx. So you can call x raised to m as function u and sin nx as a function v in integration by parts. So what is value of this integration? The value of this integration will be, see, what is value of this integration? X raised to m will be as it is, and what is integration of sin nx? See, so what is integration of sin nx? It will be minus cos nx divided by n. See, so this value of integration of sin nx minus, next, what is derivative of x raised to m? That is m into x raised to m minus 1. So I'm taking derivative of u, that is derivative of x raised to m, that is m into x raised to m minus 1, and integration of sin nx. What is that? It is again minus cos mx, sorry, it is cos nx divided by n and dx. First, you can simplify it a little bit, and it will be, see, it will be x raised to m or minus x raised to m cos nx divided by n, and this minus it will be plus, and you can take this m upon n outside of integration, that is m upon n integration of x raised to m minus 1 into cos nx dx. Is it okay? M upon n integration of x raised to m minus 1 into cos nx dx. So you can call this integration as suppose integration 1. See. So next, so I should find value of this integration. Again, I will use integration by part. So I don't know the value of this integration. So for that, I'm again using integration by part. Again, using integration by parts. So we obtain. So what do you obtain? The value of integration, that is integration of x raised to m minus 1 into cos nx dx. So it will be, so again you are using integration by part, and therefore x raised to m minus 1 will be u and cos nx will be v. So using the rule of integration by parts, so you will get x raised to m minus 1 as it is, and here what is the integration of cos nx? It is sin nx upon n. Is it okay? See, minus, so integration of, so in integration it will be derivative of u, so it is m minus 1 into, see, x raised to m minus 2. This is derivative of x raised to m minus 1. And what is integration of cos nx? It is sin nx divided by n dx. So further you can simplify it little bit, and you will get, that is x raised to m minus 1 into sin nx divided by n, and minus, so you can take m minus 1 divided by n outside of integration, so it will be m minus 1 divided by n, and it is integration of x raised to m minus 2 into sin nx dx. So you can call this integration as suppose equation number 2. So from 1 and 2, so I'm substituting value of this integration in equation number 1. So here I will put this value, and then I will further simplify it. So what I will get? So next, substituting yeah, an equation 2 in an equation 1. So we get, what do we get? Integration of x raised to m sin nx dx. It will be, so minus, c here. So first term will be as it is. I'm just putting value of this integration from 2. So it will be minus x raised to m cos nx divided by n as it is, plus m upon n will be again same, and I'm putting value of this integration which is equal to this. So I will put this value, see here, see. So I will get integration of x raised to m sin nx dx. So further I will simplify it a little bit and I will write it in required form. So it will be minus x raised to m cos nx divided by m plus m upon, or in write m into, or m upon n square. So what we have written and required reduction formula, yeah, it's okay. So it will be m into x raised to m minus 1 into sin x divided by n square. So that is second term. What is third term? That is minus. So m into m minus 1 divided by, or in right, that is x raised to m minus 2 into sin nx divided by, sorry, integration is there. So divided by n square is there, and this integration of, just a minute. Yeah, integration of x raised to m minus 2 into sin nx dx, and this is the required reduction formula. So which is required reduction formula 2. So in similar way, we'll see some illustrative examples for this reduction formula. So let us solve first example. So example first, evaluate, or I'll write using method of integration, evaluate integration, suppose x cube sin nx dx. So let's solve this problem. So we have reduction formula. You should write this reduction formula first. So we have reduction formula 2. What is that reduction formula? That is integration of x raised to m sin nx dx, that is equal to minus x raised to m. So I will simply copy it. Yeah. So don't waste your time. So we have reduction formula x raised to m sin nx dx equal to this. So using this, I will write this as equation number 1. So what we have to find? We have to find integration of x cube sin nx dx. So let us put m equal to 3 in reduction formula 1. So put m equal to 3 in an equation 1. So what we get? So we obtain integration of x cube sin x dx. sorry, sine nx dx. So what I am getting here, yeah, or you can take sine nx or you can take sine x, it's okay, no problem. So we can change this, and you can find suppose integration of x cube sine x simply, not 10x. So I'm putting here n equal to 1 and m equal to 3 in reduction formula 1. So here put m equal to 3 and n equal to 1. What I did, just a minute. Yeah, where it is, x cube sine x dx. So we have reduction formula 1. So here we are putting m equal to 3 and n equal to 1 in reduction formula 1. So we'll get x cube sine x dx equal to, so what is that? It will be minus x cube cos x divided by n. What is n? It is 1. So plus m, that is 3, x m minus 1 means 3 minus 1. See, into sine x divided by 1 square, and it is minus. So what is 3 into 3 minus 1 divided by 1 square integration of x raised to 3 minus 2 into sine and sine x dx. See, so further you can simplify it and you will get minus x cube cos x plus 3 x square sine x. So what is this? Minus 3. So 3 minus 1, that is 2. So 3 into 2, that is 6. You will write that is 6. And what is that? X sine x dx. So next you have to find this integration. And for that you have to use this reduction formula same. So again substituting, or you will call it as suppose equation number 2. So now substitute or put n equal to 1. What is problem? N equal to 1 and m equal to 1. In 1, what we get integration of x sine x dx. And what is that? So what is that reduction formula? It is minus x raised to 1. It will be cos x upon n, that is 1, plus m, that is 1. So x raised to 1 minus 1, that is 0, into sine x divided by 1 square and minus. So here, what is m? It is 1 into 1 minus 1 divided by 1 square, and that is integration of x raised to m minus 2, that is 1 minus 2 into sine x dx. But you can see, so this quantity will be 0, and therefore whole this integration will be 0, and therefore last term will be 0. And what is value of this integration? So that will give us, so value of this integration will be minus x cos x plus x raised to 1, 0, that is 1, plus sine x. So you call this equation as suppose equation number 3. So I will substitute value of this integration here, and you will get value of this integration, that is x cube sine x dx. So next So finally, substituting equation 3 into, we get integration of x cube sine x dx, and that is equal to, see, what is that? So it will be see. So this is equal to minus x cube cos x plus 3x square sin x minus 6 times x into sin x dx. So it is from equation number 3. So here we are substituting this value. See, this value from equation number 3, which we already find here. So what is that? It will be minus x cos x plus sin x. So I will erase it. It is, see, minus x cos x plus sin x. And let us simplify it. So you'll get minus x cube cos x plus 3x square sin x plus 6x cos x minus 6 sin x, and this is the required solution of given problem. So required answer. So this is the second reduction formula. So I will again give you some homework. You can do it at home. Homework. So it is compulsory. You should do it at home. So using reduction formula 2, evaluate the following integrations. So first is that integration of, suppose, x cube sine 2x dx. Second, x raised to 5 sin x dx. Third, x raised to 7 sin 5x dx. Third. Fourth, integration of, suppose, x raised to 9 sin 2x dx. Fifth, integration of, suppose, x raised to 7 sin 3x dx. So do it at home. Yeah. So next part we'll see in next lecture. So we'll stop here.